In this video, I'm going to make a connection between what the circle, ellipse, hyperbola, and parabola look like algebraically in an equation. So a circle happens, and I'm going to draw a circle. So that's a circle, and a circle happens when x squared and y squared have equal coefficients. X squared and y squared have equal coefficients. So I'll give you an example of what an equation might look like. If I have negative 6x squared minus 6y squared plus 12x minus 24y equals negative 100, x squared and y squared have equal coefficients. They are both the same number and the same sign. So they are the same exact value. Now an ellipse happens. I'm going to try and draw a picture of an ellipse. Let's see if it'll let me do this. There we go. That's an ellipse. So an ellipse happens when x squared and y squared have unequal coefficients but the same sign. So x squared and y squared have unequal coefficients, but they are the same sign. So they're both positive or both negative. So I'll give you an example here. I'll give you a couple of examples so that you can see. X squared plus 6y squared minus 5x plus 20y equals 40. So here's our unequal coefficients, 1 and positive 6, but they have the same sign. Now if they're both negative, another one would be negative x squared minus 6y squared. And then the rest doesn't really matter. Equals 1. It doesn't really matter what the rest is as long as your quadratic terms have unequal coefficients and the same sign. Now a hyperbola, I like to try and draw a picture of what these look like. The hyperbola is either going to be two parabolas opening away from each other left, right. I'm trying to do this and I'm just doing this a little bit. There's no sharpness about it. It's definitely a parabola opening left and a parabola opening right, or a parabola opening up and a parabola opening down. So you can see all three of these, the circle, the ellipse, the hyperbola, these are examples of relations that are not functions because they do not pass the vertical line test. So your hyperbola is two parabolas that are opening left, right, or parabolas opening up, down. Now, a hyperbola happens when x squared and y squared have opposite signs. X squared and y squared have opposite signs. One is positive, one is negative. So an example of left, right, up, down, you could have negative 3x squared plus 3y squared minus 2x plus 4y equals negative 45, or you could have positive 2x squared minus 7y squared plus 5x plus 3y equals negative 20. These are two examples of hyperbolas. And what makes them examples of hyperbolas is one of the quadratic terms is negative and the other one is positive. Same thing here. The x squared is positive, but the y squared in this situation is negative. The numerical coefficient does not matter. It's all about the signs for the hyperbola. Now the parabola, we're used to parabolas opening up or down. So a parabola is going to be opening up or down because that's what we're used to. Or now we're going to have left or right. And my left and right seem to be sharp, but they're not sharp at all. Now let me use some highlighters here. It's going to be up, down, or left, right. And I'm going to provide a couple of examples here. Your equation has only one squared term. Has only one squared term. Or variable. Let's even say variable. One squared variable. So we'll have y equals x squared minus 4x plus 2. This would be an example of a parabola opening vertically. And not only vertically, but it would open up. But the big part here is opens vertically. Why does it open vertically? That's because your x variable, your input, your horizontal axis, is the variable that is squared. You could also have x equals y squared plus 2y minus 3. That's going to be an example of a parabola that's opening horizontally. Horizontally. Now I'm going to take this just one step further because I like to do that. Opens vertically. Remember we said specifically this one's going to open up. And opens horizontally, this one's going to open right. And we'll talk more about that. You can see the grids that are occurring here. We're going to talk more about that. But before we get into our graphs, let's see if we can identify from the equations what these equations represent. Do they represent a circle, an ellipse, a hyperbola, or a parabola? So here are the first 6 problems. Go ahead and press pause and you can write those down. Here's 7 through 12. Here's the next 6 problems. So go ahead and press pause and write these down. And here are the last 5 problems. Go ahead and press pause and write these down. And in the next video, we're going to come back and we're going to go through the answers to these 17 problems. What conic section is it? Is it a circle? Is it a circle? An ellipse? A hyperbola? Or a parabola? Parabola. Which one is it? Name the conic section. Name the conic section.